We are going to see two's complement arithmetic. So we are going to consider 4 cases. Okay, the first case, a plus b. This one, both a and b are positive numbers. Case 2, negative a minus b. So this one involved with two negative numbers. Okay, case 3, a minus b. Okay, one positive and one negative. Okay, uh, the number with larger value minus the one with a smaller value. Okay, case 4, one negative number and one positive number. The negative number is to be added with a positive number. Okay, so we're going to see one by one. Okay, first one, a plus b, two positive numbers. Since both a and b are positive, the result will also be positive. So there is no need to use the two's complement. So if you are going to add two binary numbers with positive values, you don't have to implement two's complement number. Though the question mentioned two's complement number, please do not inverse. You don't have to inverse the number because for the inversion only needed to generate negative numbers. So for positive numbers, just do the normal conversion from decimal to binary and add. Okay. Okay, for example, let's see. Okay, let's say you want to add 9 plus 4. Okay, case 1. Oops. Case 1, two positive numbers. Okay. Okay, for example, 9 plus 4. So we have to show the binary addition. So 9. Okay, so we need 4 bits. Okay, to represent 9, and then plus with 4. 4, 0, 1, 0, 0. Okay, add. Just perform normal binary addition. Okay, so you have this. Okay, 9 plus 4, it is 13, right? So when you check your answer, this one, okay, correct, 13. Okay, so this is the first case. Okay, before we go to the next case, let's see one term here, overflow. What does it mean by overflow? There are cases when an operation produces a result that exceeds the range of the number system, producing a condition known as overflow. For example, when we add two numbers with the same sign, which produce a sum that is larger than the largest representable number, we can obtain an incorrect result. Okay, as a rule, overflow occurs when the sign of the sum is different from the signs of both addends. So the sum of requires more than the allotted bits to represent it. Okay, for example, just now we perform 9 plus 4. Okay, so the answer is 13. Okay, so what happened? Actually, for this addition, it is considered as overflow. Why? Because the number is positive, but it starts with 1. Okay, so it can be misunderstood by the computer. The computer might be treating this number as negative because it starts with 1. So what should we do to handle this? Actually, we need, instead of 4, we need 5 bits. Okay, for this one. So what happen if I add another additional bits here? Okay. Okay. So suppose if we use 5 bits, okay, what happened? Okay, so now the number start with 0. Okay, meaning that it is positive. So the computer won't be misunderstood about the sign of the numbers. Okay, so that's what it means by overflow. Okay, so overflow occurs whenever the sign of the sum is different from the signs of both addends. Okay, bila you tambah dua nombor, nombor positif, dua-duanya nombor positif tapi you dapat negatif. So itu bermaksud overflow. Okay, so usually in the exam, you will be told by the question how many bits to be used. Okay, for example, compute 6 plus 3 using 5 bits, compute 12 plus 7 using 6 bits. Okay, okay, this one I think you can do on your own. Okay, next. Okay, case 2. Okay, how can we solve this minus negative a minus b? Okay, so this involved with two negative numbers. So first we can use, okay, let's try this one, negative 3 minus 2. Okay, I'll show you the first one, negative 3 minus 2. Okay, case 2. Both numbers are negative. Okay, so first get the binary number for 3. So 3, okay, we try to represent with 4 bits first. 0, 0, 1, 1. Okay, for 2 we have 0, 0, 1, 0. Okay, I'm using 4 bits. Okay, so how to perform negative 3 minus 2? So we have to find negative 3. How to get negative 3? So you inverse 1, 1, 0, 0, and then plus 1. So you get 1, 1, 0, 1. Okay, this is negative 3. Okay, this is negative 3. Okay, negative 2 we can get by inverse 1, 1, 0, 1, then plus 1. Okay, okay. So negative 2, if we rewrite negative 2 minus 2, negative 3 minus 2 equal to, also we can rewrite it as negative 3 plus negative 2. Okay, so that's how we can perform. So just take the value, negative 3 is 1, 1, 0, 1. Okay, take this value. Okay, 1, 1, and also this one. So you have to add two numbers. Okay, so we are going to add these two numbers. 1, 1, 0, 1. Okay, negative 3 plus with negative 2. Okay, 1, 1, 1 plus 1, 2, then 3. Okay, so now this is the answer. Okay, so if you look at the answer, okay, when you add negative 3 with negative 2, you're going to get 1, 1, 0, 1, 1. Okay, since you are adding for 4 bits number, okay, kedua-duanya 4 bit. and you get 5 bits. You dapat 5 bit. Okay, you can discard the leftmost bit. Yang lebih itu you can discard it. Okay, you can discard. Okay, discard this one. So what is left? Only 1011. Okay, should be if you calculate manually, -3 -2. So you will get supposed to be -5. Okay, now we are going to check whether 1011 here, is it -5? Okay, so we try to perform the inverse process 1011 to check the value. Okay, so 1011 we want to check. So how to check? Okay, this is negative numbers. Okay, when we look at the sequence, this is negative numbers because it start with 1. Okay, the leftmost here is 1. Okay, so to get the value, you have to inverse 0, 0, then plus 1. So when you finish, you get the answer is 5. So meaning that the value before you inverse is actually negative or -5 or negative 5. Okay, so meaning that your answer here is correct. Negative 3 minus 2 equal to minus or negative 5. Okay.